Hello friends, grab your coffee, grab your cookie, and today keep both far away from any drywall cutting table because we are talking about gypsum dust. Yes, the fine white powder that floats everywhere when cutting drywall, processing plaster, sanding joint compound, or handling gypsum board. I am Michael Klepik, and for 15 years I have been designing dust collection systems for construction materials, drywall manufacturing, plaster plants, and mineral processing lines. Let me show you why gypsum dust requires much more attention than people think. What gypsum dust really is, technical description. Gypsum dust comes from drywall cutting and sanding, gypsum board production, plaster mixing, grinding of calcined, gypsum bag dumping and conveying systems. Technically, first, particle sizes range from 1 micron to 50 microns. Second, the airborne fraction from 1 micron to 10 microns is the most harmful. Third, bulk density ranges from 800 to 1,100 kilograms per cubic meter. Fourth, gypsum dust contains calcium sulfate and additives such as starch or glass fiber. Fifth, when wet it becomes sticky and cakes onto surfaces. Gypsum dust is deceptively fine, persistent, and easily airborne. Where gypsum dust appears in industry, you will find gypsum dust in first, drywall manufacturing lines, second, joint compound sanding operations, third, plaster mixing and bag dumping, fourth, gypsum grinding and calcination plants, fifth, recycling of drywall waste, sixth, construction sites during drywall installation, seventh, cutting, routing, trimming of gypsum boards. Every step of gypsum handling releases dust. Why gypsum dust is dangerous health hazards. First, gypsum dust irritates the lungs, nose, and throat. Second, additives like silica or talc increase respiratory risks. Third, fine fibers from reinforced drywall irritate eyes and skin. Fourth, chronic exposure may worsen asthma. Fifth, OSHA regulates airborne nuisance dust levels. Equipment hazards. First, gypsum dust is mildly abrasive and accelerates wear. Second, moisture causes dust to harden inside ductwork. Third, accumulated dust leads to filter clogging. Fourth, dust layers increase housekeeping challenges. Fifth, fine dust infiltrates motors and electronics. Gypsum dust may look harmless, but it creates real problems. Combustibility. Gypsum itself is not combustible because it contains bound water. However, first, additives like paper fibers are combustible. Second, joint compound often contains organic binders. Third, dust layers can burn if contaminated with wood or polymer dust. Fourth, NFPA still requires dust hazard analysis. Fifth, some gypsum board plants handle combustible additives, so gypsum facilities still require dust control and regulatory compliance. Behavior of gypsum dust in airflow engineering-wise. First, gypsum dust is extremely light and stays airborne easily. Second, moisture causes clumping and bridging inside hoppers. Third, fine particles travel long distances with airflow. Fourth, dust cakes deeply into filter media. Fifth, gypsum fines increase pressure drop quickly. I designed duct velocities from 4,000 to 5,000 feet per minute for gypsum applications. Filtration equipment that works best. Foihen cartridge collectors, best for fine airborne gypsum. First, membrane-coated cartridges resist clogging. Second, strong pulse cleaning removes caked dust. Third, anti-static media optional for board plants. BagHouse Blizzard ideal for heavy sanding and grinding operations. First, rugged bags tolerate large dust loads. Second, good for continuous production plants. Third, dropout chambers reduce media wear. Additional needs: hopper vibrators to prevent bridging, moisture-resistant filter coatings, corrosion-resistant materials. OSHA and NFPA compliance. Gypsum dust is regulated by OSHA. First, permissible exposure limits for nuisance dust. Second, hazard communication for additives. Third, required housekeeping to prevent buildup. Fourth, PPE requirements for sanding areas. Fifth, exposure assessments during peak production. NFPA gypsum facilities may require: first, NFPA 652 dust hazard analysis. Second, explosion vents when combustible additives present. Third, proper grounding and bonding. Fourth, housekeeping under OSHA and NFPA guidelines. Dust collector system design. Gypsum dust is light, sticky, and prone to caking, so the dust collector must be engineered carefully. I design: first, a differential pressure sensor to monitor filter loading and prevent clogging. Second, automatic hopper discharge to avoid moisture-related bridging. Third, bulk bag super sack collection because gypsum dust fills containers quickly and cleanly. Fourth, hopper walls with steep angles and smooth finish to prevent material sticking. Fifth, fully grounded and sealed ductwork to avoid infiltration and plugging. Sixth, pre-separation or dropout zones to reduce filter stress. Seventh, maintenance-friendly access for cleaning hardened dust deposits. This system-level design ensures stable performance and minimizes downtime. Gypsum dust may look like simple white powder, but it is airborne, irritating, sticky, and capable of clogging equipment fast. With high-efficiency filtration, strong airflow, and automated discharge, gypsum dust can be controlled safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, gypsum belongs in your drywall, not inside your ductwork. See you in the next video.